Hi everyone, so today we are going to do one problem called first duplicate value. So we need to write a method where it takes one input and takes an input as an array and gives an output as a number. So what we have to do to this is we have to find the first duplicate value. So first duplicate value means, so suppose we have two, that first duplicate value of this 2, so we found 2, so this is the first duplicate value. So uh, in the end we have to do is the duplicate values index must be the lowest. So 3 also has a duplicate value, but the duplicate value of 2 is the lowest because the index of 2 is 0, 1, 2 and 3. So but whereas the duplicate index value of 3 is 0, 1, 2, 3, 4 and 5. So 2 is lower, so we need to return 2. So let's see another example. So duplicate value is 3. Okay, so we need to return first duplicate value of 3. First duplicate value is 3, so we need to return 3. Why? Because 0, 1, 2, 3, 4, duplicate value of 3 is 4, but whereas for 2 it is 5, so 4 is the lower one, so we need to return 3 as the output. So that's it. So if there are no duplicate values, it should return -1. And one more important thing we need to note down here is the numbers over here will be in the range 1 to n, where n is the length of the array. So length of the array is 1, 2, 3, 4, 5, 6, 7. Okay, so there can't be any element greater than 7 over here. So all the element has to be less than 7 or less than 7 inclusive. So that's it. So there are three approaches to solving this problem. So the first problem, let's look at the first problem. First solution. The first solution is the brute force solution. So for example, we have 2. So and then I'll create one variable called lowest index, li. Okay, li is equal to, so what we do here is we first check for 2. So the duplicating index is 0, so we check here, it's not equal to 2, we check here, it's not equal to 2, we check here, it's not equal to 2. So using 2 for loops, we iterate for 2, we iterate for this whole thing. 1 we check for 1, we check for 5, we check for 2, so 2 comma 2 there is a match, so 0, 1, 2 and 3. So lowest repeating index is 3. Next we make 1 point over here. So after that we check for 1. Is it repeating? No. Is it repeating? No. Is it repeating? No. Is it repeating? No. So next again we move it here. So 5, nowhere it's repeating. So next 2, nowhere it's repeating. So next 3 also nowhere it's repeating. But the index of 3 is very much greater. So this 3 is 0, 1, 2, 3, 4, 5. So 3 is lesser than 5, so we should not replace the lowest index. So the lowest index must be 3 only. Next we go here, it's not repeating. We go here, it's not repeating. So we return this array of li, that is we return the third element 0, 1, 2, 3. So that is 2. So we return the third element. So the same thing we do over here. We check for the lowest repeating index. So over here it will be 0. If when we are going for 2, we will check for all this thing. We will check for 1, 5, 3, 2 and then 2. So we get li is equal to what, 0, 1, 2, 3, 4, 5. Li is equal to 5. So but then we move on, we keep this one over here. So when we check for 1 5 3 2 2, no repeating, it's not repeating. So next we check for 5, again none of the elements are repeating. Next again we check for 3, next so 3 is repeating. So what is this repeating element index? 0 1 2 3 4. So repeating element index is 4, so that 4 is lesser than 5. So we have to replace this one by 4. So next again we check 3 repeating, no. 2 is it repeating? No. Next 4 repeat is no, so it's not repeating anywhere. So we need to return 4, the element at index 4. So 0 1 2 3 4. So this is the output. So at 4 3 is there, so return the output. This is the first approach. So let's look at the second approach. So the second approach, so this is O of n square times, since we are iterating throughout the loop twice. So and it is O of 1 space, since we are just like returning one number. So now let's look at the second approach. So the second approach is using one data structure so we can use a hash set. So in a hash set only unique elements can be stored. So it's very easy, this step is very easy. So we just have an hash set described, so is equal to, so hash set, so 2 is there. So first again we move this one over here. So 2 is there in hash set? No, it's not there, so put 2 inside the hash set. Next we move this one. Is 1 there in the hash set? No, it's not there in the hash set, so put it in the hash set. So hash set is constant time lookup, so it's very efficient. So next again we move 5. So is 5 there? No. So next we go over here. Is 2 there? Yes, 2 is already there in the hash set, so we can just return 2, since it's already present in the hash set. So we return 2. So that's it. We just keep adding the element into the hash set. If it is already present in the hash set, we give that as the output, or else we just add it in the hash set. So let's do this. Let's look at the same thing over here. So hash set is equal to so here we have 2, so 2 is not there in the hash set. Next we move this one. 1 is also not there in the hash set. Next we move this one to 5. Next 5 is also not there in the hash set. So next we move to 3. 3 is also not there in the hash set. And next we move to 3. Now 3 is again there in the hash set. 3 is now there in the hash set, so we just return 3. So that's it. So this is the easiest one. So now let's look at the last solution. Just 1 second, I'll just clean up this. So Now for the last solution, you need to it's not writing. Shit. Okay, so now for the last one, what we do is, so you need to understand this ones. So elements present over here are from 1 to the length of the array. So it starts from 1 and goes up till the length of the array. So these are the possible elements. So in that case, each of the element can be attributed to an index of the array. Yeah, so how each of the element can be associated to an index of the array is by doing -1. So if we do -1, so we get 2 minus 1, it will point to the first index. So if we do 1 minus 0, 1 minus 1, it will point to the 0th index. If we do 5 minus 1, it will point to the 0, 1, 2, 3, 4th index. So like that, so that's how we can get the index, right? So each number, if we do -1, we will get the index. So with that information, we can solve this problem more efficiently. So let me tell you how. So if we do math dot abs means absolute, so absolute is nothing but just making, if it is -2, so we get a +2, if it is -1, we get a +1. So math dot absolute -1. So here it is pointing to 2, right? So if it is pointing to 2, we first number is 2, so we do 2 minus 1. So if we do 2 minus 1, we get 1. So this one will return the index. Let us write it down. So this is the index. So if we do 2 minus 1, we will get 1. So whatever this index we get, we have to make that number in that index as negative. So here we got 1, we made this first one as negative, first index as negative. So next let's move, so next we iterate, we move to this one. So we do math dot absolute of -1 -1. So math dot absolute of -1 is again 1. So 1 minus 1 is 0, and 0, whatever that it is pointing to 0, we make it -2. Next, after that one, we move this one. So again 5 minus 1 is 4. So fourth index element na -1 multiplied. So 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. So, and then again we just move this element. So next we do 2 minus 1. So 2 minus 1 will give 1. So 1, this is the first index, right? So 1, it is already one negative number. So you need to check if it is a negative number, whatever. After doing this subtraction, you need to check whether the number present in this index is a negative number or not. So if we do 2 minus 1, we'll get 1. So here this 1 is a negative number. So as soon as you do that, we need to return this 2. So the output is 2. So let's do the same thing here, we can understand. So 2 minus 1 is 1. So we make this one as -1. After that, we move this index. Okay. So next we do 1 minus 1. So 1 minus 1 is 0, so we make this one as 1 minus 1 is, so the 0th index we make it minus. Next we move this element over here, so next 5 minus 1 is 4, so 0 1 2 3 4, fourth element now minus, so and then we again move it over here, so 3 minus 1 is 2, okay. 0 1 2 we make this one as minus, and next we move it over here, so here we do 3 minus 1 we'll get a 2, so 0 1 and 2, so it is pointing to one negative number already, minus y is already negative. We return whatever this absolute of whatever this pointer is pointing to, which is 3. So yeah, so that's it guys. So this one is the most efficient one, so we can finish this with O of 1 space, since O of n time, because we are iterating through this array once, and O of n time because we are iterating through this array only once, and where n is the number of elements, and O of 1 is we are just returning one number, so that we can keep that as O of 1. So let's do one thing, so let's implement all of these things. So let's do the brute force approach first. So int least index is equal to array, I'll just assume this one as the, let the least index be array.len gth array.length. So next I will iterate for int I is equal to 0, I less than array.length, okay, it's an array not a list, so array.length and I plus plus. So next after this we go to for so the brute force approach is where we are iterating to the one twice, so j is equal to I plus 1, I plus 1. So why I plus 1? Because if I told it, so we need to check for this number, we need to check for all of this number, next for this number we need to check for all of this number, next for this one we need to check all for this, so that's why I plus 1. So j less than array dot length j plus plus. So if array at j is equal to array of I we go inside and we check if j is lesser than least index. If j is lesser than least index, so least index is equal to j. So if it is equal, we go inside, and if whatever that position is lesser than the least index, we make this least index point to j. If any least index, if we come across a least index even more lesser than this least index, we make that one as the new least index. Okay, and then okay, after this loop we check if if least index is equal to array dot length. So if it is equal to array dot length, we return -1. So it means no element is repeating. So since array, there is no index called array dot length, since it starts from 0. So if it is equal to array dot length, it means nothing has been found. Else we return array of least index. So that's it. Let's run this. Okay, this is, remember, can't find symbol method length. Oh, here also. Okay guys, so this is the brute force approach. So let's try out the second approach, which is a hash set approach. So step 1 is create a hash set. So set is equal to new hash set to have a string. So we iterate through that one. For int I is equal to 0, I less than array dot length I plus plus. So if set dot contains, if it doesn't contain, if the set doesn't contain array of I, if it doesn't contain, you add it. Set dot add array of I, else if it doesn't contain that, we add it. If it contains, we just return array of I. So if nothing is returned from here, we just return -1. Let's check this. Okay, this is not a string, sorry, this is an integer. So, integer. Okay, so this is the second approach. So this approach will have O of n time, and O of n space, because we are creating one new hash set, so that will occupy space. So now let's look at the third method. So what is the steps in the third method? So first one, one second. So first one, we create the pointer int create pointer. So int, wait, we don't need to do that, we just let it out. So step 1, iterate for int I is equal to 0, I less than array dot length I plus plus. So after that, I'll create one index int index is equal to that dot abs array of I minus 1. After, wait, be careful here, we should only do mat.abs of that number, not to the whole thing. So once you get that index, make that index negative. Okay, so how do we make that? So array of I is equal array of index is equal to minus of array of index. So after making that index negative, so first only we should check it. If array of index is lesser than 0, if array of index is lesser than 0, we return array of I. If it's not satisfied, it goes over here and we makes it minus, and next again it goes back up. Okay, we should return the absolute value. See, for example, if we are returning, if it's minus, we shouldn't return minus, we should only return the absolute value. mat.abs. Let's run this. Okay, if it comes out of this loop, we need to do return -1. So yeah, that's it guys. Thank you for watching.